Okay, let me start to what you will learn from the first meeting. So, okay. So, the title of this meeting is Basic Concept of Statistics. Basic concept. So we are talking about basic concept. If before this meeting you don't understand, it's no problem. But although I'm sure that you already understand, at least you already read about the statistic, yeah, before you study in ABB University, because in SMA, if I'm not wrong, yeah, in mathematics, if I'm not wrong, in the books, mathematics books, you have also already learned about what is mean, median, modus, standard of deviation, and so on. In this course, we will also learn again about that. Yeah. So in this first meeting, I will explain to you about what and why statistic. Why you need statistic, and then what statistic, and why you need statistic, or why everyone you need statistic. And then after that, I will explain to you about the understanding of populations and sample. What is difference between population and sample? And then after you understand about that, the concept of population and sample, and then you will learn about descriptive statistics and inferential statistics. And then definition of variable, types of variable, and measurement of scale. Yeah. Good. Okay. After this course, the first meeting, yeah, you should be able to explain about how decisions, yeah, are often based on incomplete information. You should also be able to explain about what statistic and why you use statistic. You should also be able to explain about population versus sample, parameter versus statistic, descriptive and versus inferential statistic. And then describe about random sampling and be able to explain about the difference between descriptive and inferential statistic and variable, types of variable, and measurement scale. So today is more topic or subtopics is a little bit much. Yeah. So after this, you have to learn again, heard again this course, or you read also the slide that I have already shared to you. Yeah, because that it could be difficult to understand. So now we are talking about statistics in bahasa. So sometime, yeah, let me also explain a little bit statement or words in English to bahasa. Statistics in bahasa is statistika. Statistics is statistika, not statistic. It is different between statistika and statistic. So we are talking now about statistics with S. Yeah. If my voice not clear, let me know, yeah. Don't hesitate to let me know. So, every time, everybody, every institution, yeah, are always producing the data. Although sometimes you don't feel that you produce the data. For example, today, one of you is driving car. Although this is not good for me in this course, this is just activity. or you sit, or you learn, or you heard this course. This is activity. From your activity, actually, you produce the data. For example, how long I sit, how long I write, how long I heard. So you produce the data. 1 hour, 30 minutes, and so on. Yeah. For example, before you start with this course, yeah, what you have done, yeah, what your activities. For example, you read newspaper 5 minutes, 10 minutes, 10 minutes. This is all about the data. So the proceeding of the data in institutions, every institution produce the data. Many big institutions also have big data, not just a few data for this institution themselves, but sometimes a country produce the population data, economics data, social data, agriculture data, and so on. So the point is, the data is available everywhere, and the data is all around us, around you, around me, everybody. The data is around everybody. The next question is, if you don't use the data, it will be useless. Therefore, the data needs to be utilized. The data, and then will be processed, and then after process, and then the data will be produce information. That means the data will be useful for everybody, or for our life. Yeah. Without any process to the data will be useless. But if you process the data, and then you will get the information, useful information. So, utilization of the data in daily life, yeah. This is some list of the utilization. Human life is inseparable from problem. No one has problem. Everyone have problems. So the question is, that data can be used to solve the problem, personal problem or policy problem, yeah, in scope of the local or national or international. For example, the country will make a decision based on some problem, the issue, and then they have to make a policy, and the solution of the policy has to be based on the data. What for? Because the policy will be right, on target. If any data as a basis for decision making process, and then you will get the target, the right target of the policy. So what is the tools? One of the tools is statistics. That means statistics is the tool to make a decision process making. Yeah, that's just tools. That is correct. But the tool is very important. Without statistic, it is very difficult to make a good decision or a good problem solving. So that means the first step, you have everybody have a problem, and then from the problem, and then you have to make investigation. So how do you get the information for investigation? The answer is data. Then after you get the data, and then you have to analyze the data. If you analyze the data, and then you need knowledge about how you analyze the data. So this is the statistic that you have to learn for getting a good solution from the data, and then you have to implement statistics with the statistic descriptive or statistic inferential, and then you will get a good solution. So what is statistic? This is the questions in this meeting. So the definition of statistic, there are many definitions. Some definition of statistic based on some textbook, yeah. But basically, the definition of statistic from some books have the same meaning. One expert defined statistic as science of collecting, yeah, and then after collecting, organizing, after organizing, and then presenting, analyzing, and interpreting data. What for? To assist in making more effective decision. That means you can also make a decision without data. You can answer that, but it could be that will not effective. It could be it will not accurate. Therefore, with the statistics, you can use the data. From the data, you will get information for making more effective decision. The word more effective, this is very important things. Compare without data. The other defined statistic is the art and science, not just science, but also art. Combination between art and science of designing studies and analyzing the data that those studies produce. So that means statistic is not just science, but also art. Why art? Because from the data, you have to think about how I presenting the data with which graphic, for example. This is the art. If you can make a presentation, good presentation with a good graphic and so on, and then the audience will understand easier. So that means this is what mean with the art. Art and science of learning from data. So that is Agresti defined statistics is the art and science of learning from data. The other defined statistical application are based on probability statement. So probability. This is not exactly. If you interpret something from the data, statistic will not say this, that this is the 100% true. We are always talking about probability. 90% probability that this is, for example, this mark of the machine is better than the other mark, for example, like that. This is probability. Now the next question is why do you need to study statistics? Yeah, because the collecting data Normally, the researchers, the students, you are also sometimes as a researchers. You cannot collect the data of population. You just collect some of or subset of the population, and that we call it sample to take a decision, to predict about the whole population. For example, if the number of students IBB in IBB University, for example, 10,000, and then you want to interview something about COVID, for example, it is very hard if you interview all of students in IBB University, 10,000, for example, and then you just will interview, for example, 500 students. But from 500 students, you will take conclusion about 10,000 students. So therefore, you have to learn about statistics. How you will take 500 from 10,000. You need statistics about that. Yeah. And then the other, knowing what has happened in the past can help answer questions about the present and the future. That means with the statistic, you can predict, forecast about the next data, yeah, the next situation. You can predict, for example, in 3 days it will rain or not, based on the last data. Next year, for example, you can predict what about the production of rice in Indonesia. So you need statistic for that. So component in statistical problem solving here. So the first one, you have to formulate the question, and then it could be better if you can also formulate the question, real situation, in statistical questions. Sometimes we call it hypothesis. And then after you can also after you can formulate in statistical question, and then the next step, you collect the data. After the data available, and then you analyze the data, and then after that interpret the result of the data analysis. So therefore, these are the reason for using statistical method. From the main component as I just explained to you, yeah, you need design, and then after that description, summarizing, analyzing the data, and then inference. Inference, that means making decision and prediction based on the data. And then that means the first step is designing, after the description, and then after that inference. Stepnya inference for making decision and prediction. Okay, so now we are talking about the concept of population and sample. Okay. So the 4 words in this slide: population, sample, parameter, and statistic. Look at this. This is not statistics with S. This is without S. Only statistic. In Bahasa, if with S, and then we translate with statistica. Without S, we call with statistic. Yeah, there's difference between statistica and statistics. If statistic as a science, so you write with S, statistics, this is science. But if statistic, this is not science. Let me explain to you first what population and what sample. Definition population is collection of all items of interest or under investigation. Who develop or who define population? Everybody may make a definition of population. For example, I define that number of students in the first year of EPB University as population. I define in the first step of the research. The other persons define population as all of students of IPB University. Depend on me. Even I may define population as the students in international classes year 2022. That means 14 students in this class I define as a population. It's no problem. It depends on the research. It depends on the researchers. Because definition of population is very important for what? This is for interpretation of the population. If we define population as all of students of IPB University, for example, 10,000 students, and then sample is an observed subset of population. That means some of population that we take randomly. If the population 10,000, for example, the number of sample, it could be 2,000. 20% of that, for example. But if the population, for example, I define students in my class, in international class, this year, only 14 students, for example, and then I take sample only 4%, for example. So different, you know. And then I will also take a decision or inference based on the definition of the population. If the population is only my student in this class, so after I take the data from you, I should also take the inference only just for my classes. I may not interpret for classes outside of this class. So normally in statistic, we give with a symbol with a big N, yeah. If a sample is with small n, if the big, that means this is population. If the small, this is the sample. This is just only symbol. So, what is relationship between population, sample, and with this word parameter and statistic? Definition of parameter is specific characteristic of population. For example, yeah, I define population as all students in my classes, and then I ask you, for example, how much you spend money every month for food, for example, and then I collect the data from everyone, from all of you. And then after that, I calculate average, for example. Or per month, 300,000 rupiah, for example. Because I calculate for all of you, and then I call, this is the parameter. That means specific characteristic of population. That means average of spending for food, my classes is 300,000 per month. But in other issues, I cannot interview all of population, I just take some of you. From 14%, for example, I just take 5% randomly from you, and then I ask you how much you spend for clothes, for example, per month. So, and then I calculate 150,000 rupiah, for example, on average. So, because I don't take all of the data from all of you, I just take a sample. So, the average 150,000, this is statistic. Without S, yeah, statistic. That means specific characteristic of sample. So many variables. You can also collect the data: height, yeah, weight, how many kilogram of you, yeah, how many you spend your time for learning every day on average. This is variable. If you calculate based on the population, and then you call parameter. If you calculate based on the sample, you call this is statistic. So what is relationship between statistic and parameter? Statistic is estimator of parameter. Parameter estimator. That means, although I ask only 5% from you, but I use the average 150,000 rupiah for clothes per month. This is I use this average to predict of population. And then I say that average of the students in my classes spending for clothes is 150,000 rupiah. So this is statistic to predict parameter if we cannot collect the data from all population. This is easier to describe what population and sample. This is population consisting of many individuals, and then from this we take a sum of how many percent, for example, from population will be taken as a sample. It depends on some consideration, some reason. It could be you have consideration with the budget, time, and so on, yeah. And then you take just 10%, 5%, 7% of that. So this is the description about population, sample, and parametric and statistic. If you collect the data, all individual data in population, and then you calculate, and then you call with parameter. If you just take some individuals from population, and then you calculate, and then you call this is statistic. Yeah. Okay. Sorry, there is mistake here without S, yeah. Oh, sorry, because some value. This is statistic, that means plural, yeah, not statistic as a science. This is parameters, that means statistic in this case is average, for example, median, modus, standard deviation. Yeah, this is plural of the statistic. So, example of the population, as I mentioned before, names of all registered voter in United States or in Indonesia, incomes of all families living in beach, yeah, and many other things, yeah. Random sampling. So the next question is how you take sample from population. There are some methodology, some method, how you take sample from population. The first one, the simple one, yeah, is random sampling. Sampling is methodology, and then we call it simple random sampling. It's produced in which each member of population is chosen strictly by chance. That means every individual in population have the same probability or possibility to be chosen. This is simple random sampling. Yeah. So each member of population is equally likely to be chosen. With the mathematical word is have the same probability. Every member of population has same probability to be chosen. Yeah. For example, if the population's size is 1,000, and then the sample size you want to take 100 as a sample, that means every member have 100 0.10 or 10% to be chosen. Yeah, because 100 divided by 1,000 or 1,000 divided by 100. Every member has probability 0.1, yeah, to be chosen. Yeah. Good. So we call that with as a random sampling, simple random sampling. Yeah. So after you collect the data, yeah, and then you have to analyze the data. In statistics, some books define that there are two kinds of statistics. The first one is descriptive statistics. The second one is inferential statistics. What is different between descriptive and inferential? Descriptive statistics, normally you analyze the data with the easier method. You just using graph, you just using table, yeah, to explore the data. For example, using graph or number to get information from the data. It is different with inferential statistics. Inferential statistics more complicated than descriptive statistics, because in inferential statistics, you will be use predictions method, forecast method, or estimate that are used to transfer information to knowledge. That means, for example, in inferential statistics, you have to conduct about testing of hypothesis, prediction. You predict next week will be rain or not. Next year, the production of rice will be increase or decrease. So if you use statistics for this one, and then we call it inferential. But if you just description about how many % of the students in APB University male, how many % female, how many % stay in Jakarta, how many % outside of Jakarta, and so on, this is statistic descriptive. Okay, so this is the picture about relationship between population sample. If you have population and then you take some of them, and then we call this is sampling. This is sampling is procedures for choosing some of the individual in population as a sample. This is sampling is a process for selecting or for choosing individual from population, and then will be used as a sample. After that, from here, and then you analyze the data, and then it could be through descriptive analysis, just summarizing the collected data with the table, with the graphic, and so on. And then the other side, you can also use inference statistic. And then in the inference statistic, and then you will get the level of confidence. This is statistic is not 100% correct, yeah, but we use the level of confidence, and then we will make a statistical inference based on the data. Okay, So, descriptive statistic. This is some example of the descriptive statistic, and then you will learn the method of the descriptive statistic in the next meeting. But in this meeting, I just informed you some of example of descriptive statistic. Yeah. The first one is collect the data. Yeah. You can use the survey, or you can use experimental design, yeah. And then after that, you present the data through the table and graph, for example, like this. This is statistic data. And then after that, you summarize the data. Only you just inform about mean, sample mean, yeah. With this formula, sigma xi divided by n. This is sample mean. This is still descriptive statistic. Okay, this is just some technique for collecting the data in outside, not just in foreign country, but also in Indonesian. You remember in the president election, some survey method used by people, for example, to calculate based on exit poll, polling opinion, and so on. This is just description. How many percent, for example, in the elections, choose the President A, President B, and so on. Yeah, this is still description. This is some other descriptive statistic. For example, this one, graphical with tabular. You will learn about when you will use this table. Yeah, for example, this graph, for example, has to be used if your data is numerical. The other, for example, yeah, for statistical inference, you will learn about estimation, and you will learn about hypothesis testing. If this is inferential statistic, if just you show the simple graphic, simple table, and so on, and then this is as a descriptive statistic. This is another example of descriptive statistic. For example, graphical on tabular. This is table segment junior high schools, how many percent preference on a TV program. This is a table, and then you can also use this one, this graphic pie chart we call. Yeah. So from this table, and then you can also describe with this graphic pie chart, and then it could be you will just show the summary of the data if you have the data, and then you don't need to test hypothesis, and then you just show the summary of the data, minimum from this data, which data is minimum, 43 maximum, mean or average, median, modus, variance, standard deviation. This is still in terms of the descriptive statistic. So it's different with inferential statistic. Inferential statistic, for example, you want to estimate income per capita of the Indonesian population. We don't know because we don't collect the data to all population, all citizens, everybody, and so on, but we just take some people, and then you collect the data from the sample, and then you estimate income per capita of Indonesian population. So that means this is inferential, because you will take a decision of conclusion about the population, just estimation. Besides that, in this inferential statistic, this is hypothesis testing. because based on the sample. And then in this hypothesis testing, and then you will use the confidence interval. You will also use with the level of confidence 90%, 95%, and so on. So this is the term of the inferential statistic. So, for example, estimation of population mean weight using the sample mean weight. From this population, this is the population, and then you just take 1, 2, 3, 4, 5, 6, 7%, and then after that you collect the data weight of every sample, and then you calculate based on the sample, and then for estimation of the population. So this is inferential. Or testing, test the claim that the population mean weight is 120 pounds, for example. We don't know the right number of the weight of the population, but we just take some sample. From the sample, and then you test the hypothesis. Is it correct or not that the weight mean of the population is 120 pounds? So this is the hypothesis testing, and then this is the term of the inferential statistic. So definition of the inference is the process of drawing conclusion or making decision about a population based on sample result. Yeah, this is the definition of inference. So right now we are talking about variable and measurement scale. What is variable, and then what is measurement scale? Okay. Variable, by definition, is any characteristic observed in a study. Again, any characteristic observed in a study. For example, age, gender, profession, weight, height, education, and so on. This is variable. Yeah. You can give information how old you are, what is your gender, profession, weight, height, education, and so on. This is variable. So, but from some variable, you have to understand about what is the type of variable, and then what is the scale measurement of this variable. This is very important to understand about types and measurement scales. Why? Because based on this, if you understand about this, you can use the right methodology, right method for data analysis. Some method can only be used for a certain types of scale, certain type of variable, and certain measurement scales of variable. For example, if I collect the data variable gender, all of you. Oh, from 14 students, for example, 8% are female, and then 6 are male, for example. So this is the variables with the type as a discrete. The scale is nominal, so I cannot calculate with the statistic of average. I cannot say the average of gender, no. But I may say like this: mostly of the students are female, or 80% of the students are female, or the female, yeah, the students in my classes, the number of students in my classes, the number of female students in my classes more than male students. But I may not say average of gender. No. Before, you have to understand about the types and measurement scale of every variable. So let's talk first about the measurements level. Variables, the level of the measurements of variables divided by 4 types. The first one is nominal. For example, is gender and religions. The next is ordinal, education level. Next is interval, for example, IQ and temperatures. And then ratio, for example, age and weight. So you have to understand why gender is nominal, why ordinal education level is ordinal. There are different characteristics between 4 types of the measurement scale. Look at this, yeah. If nominal, you can just classify female or male. Religion, for example, is Islam, Christ, Buddha, Catholic. But from this, you cannot say this is better than the other. Different with ordinal education level. SMP is higher than SD. SMA is higher than SMP. University is higher than SMA, for example. But this is still ordinal. But you cannot say that SMA is twice higher than SMP. No. You can just say higher or lower, ordinal, yeah. But you cannot say that level education of SMA is twice better than SMP. No. Different with interval and ratio. Interval, for example, IQ. You can calculate here. IQ, average of IQ. IQ of someone is higher than IQ of someone else. Yes. And you can also calculate difference of IQ as well as temperature. Oh, 10, for example, 80 Celsius, yeah, is hotter than 50, hotter than 40, but 80 not twice hotter than 40, but different is 40 Celsius. Difference with age and weight, for example. Your age, my age is, for example, 60, and then you, for example, 20. So that means my age is 3 times older than 20, as well as weight and height. As someone with 70 kilogram, this is twice than 35 kilogram. This is ratio. Okay? So this is measurement scale or level of measurement. Difference in the other side, the data will be differentiated with type of the data, categorical and numerical. Categorical, for example, marital status, are you registered to vote, are you color, yeah, religion, for example, male or female. So this is categorical. The other side, numerical, for example, weight, age, for example, but within type of numerical, we divide with 2 types of variable, discrete or continuous. Number of children is 1, 2, 3. There is no 1.5, 2.5. No, this is discrete. It is different with continuous. If continuous weight and voltage, for example, weight, it could be 60.1, 60.2, yeah, 70.1, and so on. This is continuous. So let me check how many slides I have. 14 slides. Okay, still. What time is it? Okay. Let me continue. So the next one, we talk about data and data collection method. Yeah, what is the data? What is data collection method? So, what is the data? Yeah. Definition of data is fact on or figures collected, analyzed, and summarized for presentation and interpretation. This is the data. Fact. Fact, this is the very important word. Fact collected, this is the data. Data, a moment. Sorry. Data will not become information before analyzed, before summarized by you. Yeah. So therefore, the data, it could be, will be collected based on the period or number of observation. And then after that, the data can be classified into kind of the data. There are some data will be classified as a cross-section data. What is cross-section data? Cross-section, that means the observation will be collected just one time measurement period. For example, I collect the data about your weight today, for example, only in January 28. This is your weight. This is cross-section. But if I collect the data many times, for example, in January, and then next month I collect again your, I measure again your weight. Every month I measure your weight. So we call the data is time series data. Yeah. So time series data, that means one observation, several and regular time measurement period. I measure your weight every month, for example. So the data, the collection of the data, we call it the time series. But if I just collect one time, this is cross-section. The other is panel data. Panel data is the combination between cross-section and time series. Several observation, several and regular time measurement period. That means you, this class, all of you, for example, 14 students, I collect your weight, and then there are 14 data in row, and then I collect every month. For example, in 2 years, that means I have 24 columns. So we call the structure of the data as a panel data. The last one is space-time, one observation on several locations, not time but location. Yeah. I measure production of the rice in Bogor in Tangerang, in West Jakarta, and so on. So almost the same with panel, but the space and time, the column meaning as a location. Yeah? So, for example, this is the cross-section data. District A, B, C, D, population, yeah, how many population, how many income per capita. This is variable. Population is variable, income per capita variable, district is individual. This is only one time I measure. This is cross-sectional data. But if I observe, for example, one observation, several regular time, for example, how many sold, and then in 1981, 1982, and so on, yeah. Number of car, for example, this is time series data. Actually, this is from one firm, for example. Yeah, this is year. Different with this is panel data, this is observation, and then this is observation 1 or individual 1. This is time 1, 2, 3, 4 until T. This is observation or individual 2, 1, 2, 3, 3. And then this is variable, so we call the data as a longitudinal data or panel data. If the individual mean as a location, yeah, this is also time, so we call with space time data. Yeah. Okay. So the next one is about data collection. How you collect the data? The data in statistics, there are three kinds of the method for collecting the data. You can collect the data through experiment. The other method, you can also collect the data through survey. The other one is collecting the data through administrative. What is the difference between the three methods of the data collecting data? Experiment, we call with the experiment if the data before experiment is not available. The data will be available after you giving treatment. After you give a treatment, and then you will get the data. That means the data generated by giving treatment to an object. So we call the method is experiment. Normally, experiment is applied in agriculture or psychology or biology science. Different with survey. Survey is data is already available in nature. You just collect. Okay. For example, I collect the data about, as I mentioned before. For example, I want to know about your spending your money for food, for clothes, for pulsa, for example. The data is already available in everybody. I just collect. That means I just select a sample, and then the method will be called as a survey. The other things is administrative. You know that there are many institutions. Firm, for example, bank. You don't need to make an experiment. You don't need to make a survey. The data are already available in institution. I just come to the bank and then I just collect the data about the bank account. Yeah, how much money every bank account owner in this bank, and then how many transaction per day, and so on. this is administrative, and the data at the institution, this is administrative data. So that means the data actually, sometimes automatically recorded human activity. For example, the data about user of smartphone application, browser, and so on. That means automatically, naturally, without any effort, the data automatically already collected. So this is some example, how we explain about the big data. For example, in 2020 internet user. This is a knowledge about big data, as right now, very famous to be implemented by everyone in the research with the big data. But the definition of big data is the large, not just large or very large, but also complex. The structure is complex. So the characteristic of the big data, not just large, but also complex. So it cannot be managed with the conventional database. You have to use a big software or tools to manage the data. Not just big in form of the size, but also the variety of types of the data. Some of the data are text, some of the data images, some of the data could be sound, video, and so on. And then this data velocity, that means very in few minutes, hours, and so on, sometimes change very fast. So if you have the characteristic of the data, and then we call it the big data. So we need the skill, special skill to analyze the big data, not just some data. So at the last of the presentation in this meeting, I just want to show you at the moment there are many applications of statistics software. You can apply the statistics. You can use the software to analyze the data in area of economics issue, business issue, politics, even politics, climate, and so on. So that means a summary of the statistics that we discussed in the first meeting. You have to understand about what is statistics, what is the population, what is the sample, what is the parameter, what is the statistic, what is the descriptive statistic, what is the inference statistic, and then measurement scale, nominal, ordinal, interval, and ratio, then type of variable, categorical and numerical, and under numerical you have also continuous and discrete, as well as you have to understand about some of application of statistics in some area. So this is the material that